This example asks us to calculate three integrals involving the delta function. To do this, we need to refer to the notes. In the notes we showed on page 14 that the integral between minus infinity plus infinity, some function f of x multiplied by a delta function x minus x0, so that's a delta function centered at x equals x0, and that's when we integrate with respect to fx, that just gives f, the original function, the function just here, evaluated at x0, the point where the delta function is non-zero. So it's relatively easy to use this result to evaluate the three integrals. In A, we've got that f of x is equal to sine x, and so the result is that the integral will just be f of x, so sine x evaluated where the delta function is non-zero, and that's x0. So the first result is sine x0. The second example, in this case f of x is equal to x squared, and so what we get is we get f of x evaluated where the delta function is non-zero. In this case that's when x is equal to a. So the second example, the result is a squared. The third example is slightly more involved. We're asked to find the Fourier transform of the delta function delta x minus a. So to do this we write that, as we should know by now, f of k is equal to 1 divided by the square root of 2 pi, and then it's the integral between minus infinity plus infinity. In this case, the function we're taking the Fourier transform of is delta function x minus a, and then we get e to the minus I kx dx, like that. Although we're now taking the Fourier transform, we can see that the equation we're integrating is essentially the equation in our example up there. In this case, f of x is the complex exponential. And so when we evaluate this integral, we get 1 divided by the square root of 2 pi, the prefactor, nothing happens to that. And then we get the complex exponential evaluated where the delta function is not equal to 0. In this case, when x is equal to a. So we get the exponential e to the minus I k, and then it's evaluated when x is equal to a. So that's the result for part C.